page 76. 76. Okay? So we're going to talk about the equations of current. 教呢個無聊嘅嘢啦。好啦，交俾你知啊。沒錯啊 ，page 76. So we're talk about the equation. So I equals to Q over T. So as I mentioned that current is the flow of electrons. Okay? So you can see that. So when the flow passes through the wire, then it creates the current. And the equation is I equals to Q over T. Okay? So the units of the current can be C over seconds. Okay? Or we have a special unit which is ampere. Okay, so name after the scientist. 咁咧呢個科學家有啲咩特別啊？咁咧呢個科學家咧，如果冇記錯，佢攞諾貝爾文學獎。文學獎？係啊，OK。咁所以咧，其實就係呢個 current 咧 equals to charge over time 就係咁啦。So if there are more charges pass through the wire in 1 second, then the current will be higher. 好，咁咧呢個 equation 就好廢啦，係咪？咁咧右轉都識計啦，咁啊直接就睇後面啦。So Kate puts some new batteries in her torch. So it draws 0.58 and allowed in a total 5,400 coulombs of the charge to flow through the circuit before it goes off. So how long can she use the torch before starting off the battery? So I'll give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so what's the answer? 10秒都未計完，哇！個方塊。10800秒。好啦，咁即係幾多分鐘咧 ？Okay, so T, since current I equals to Q over T, right? So now if you want to find the times, then rearrange the equations. Make sure you get that times equals to Q over I. I the current. A 係 unit. Current 係 unit. 咁咧，所以咧佢係 0.5 ampere 啊嘛，咁你咪就咁除咗 OK， 咁咧就會計到呢個 times。咁咧呢個 times 咧就係呢個3 hours。咁咧就冇啦 current 呢條式就係咁啦。Okay, so now turn your book to page 79. Page 79. Page 79. So I give you 1 minute to do fraction number 2 and 3.
佢哋做嘢啊。
Okay, so I think you can use less than 10 seconds to find the answer. So I equals to Q over T. So the answer is 0.58. Okay, so for question number 3, so a current of 2.48 passes through a metal wire. Okay, so I find the numbers of electrons passing through a cross section of the wire in 1 minute. Okay, so the first step is to find the Q in this case, right? So you have I and T, then you can find the Q. Okay, so you can find the total Q to pass through the wire. And for each electron, it's carrying the amount of Q here. Okay, so you use the total Q to over the charge carried by one electrons, then you will find the answers. Okay, so find the total Q, and then find the numbers of electrons. So use 144 over 1.6 times 10 to the negative 19, and you will find the answer. Okay. So do you have any questions? 你都冇啦，呢樣程式係咪？有冇人有問題啊？有問題就撳字一包我聽到。So turn your book to page 83. Turn your book to page 83. 83. Okay, so do question number 9. 點解要做呢題咧？做呢題咧就係教你點樣揀呢個奶媽。你買呢個充電寶嘅時候咧，上面有數字嘅，你成日講啲咩12000啊、20000啊係咩嚟？其實就係呢個 mAh。所以你可以計下咧，你買個充電寶咧，去充你個 iPhone 幾多次？Page 83, question number 9. M 係幾多啊？揾個同我答下佢。10 to 幾多啊？10 to negative 3，你諗下 building distance 就知啦。Okay, so 2000 mAh can deliver a current of 2000 mAh of 1 hour. 好啦，咁咧你首先睇下 2000 mAh equals can deliver a current of 2000 mAh. Okay. mA for 1 hour. Okay, so for every hour, so there is 3,600 seconds. So actually, what is the unit of mAh? 其實呢個 mAh 係咩嚟嘅咧
Ampere per hour。
ampere times seconds 係咩嚟㗎？好啦，咁咧我哋首先約做先啦，咁所以咧佢就可以 provide 7,200 ampere times seconds 嘅唔知乜鬼嘢係咪？呢個係乜鬼嘢咧 ？So actually, if you still remember the equation, so current equals to the charge over time. So if you rearrange the equation, then charge equals to current times time. So equals to A times seconds. Okay, so the unit. So actually, A times seconds equals to the unit of coulomb. So when you go to the shop and buy the lima, okay, so sometimes you will see 20 kmh, right? So which means it can provide 7,200 coulombs in 1 hour. Okay? 咁咧，所以如果你知道咧，你部電話咧每個鐘要用幾多電咧，咁你就可以知道會差幾多次。你有冇發現啲充電寶越嚟越襟用啊？即係你以前可能個充電寶一定係 you can only charge one iPhone for each full charges, right? So after maybe half year, you can charge it twice. Why? 就係因為你部電話越嚟越唔襟用。Okay, so the maximum capacity of your iPhone will be decreased. Okay, so after usage. So if there is 2,000 mAh, so which means it can provide 7,200 coulomb. Okay, so your question asks that. So 1 mAh is equivalent to 3.6 units. So what is that unit? What is that unit? Okay, so you use this one. So 1 mAh equals to over 2,000. Okay, so which is 3.6 C. So that unit is coulomb. So B, what is the total amount of charge that the batteries delivers in 1 hour? So, which is 7,200 coulombs. So that's all. Okay, so the calculations about current is very low B. Okay, so there is only one equation to link the charge with the current. Okay, so which is I equals to Q over T. And now please, turn your book to page 79. Turn your book to page 79. Turn your book to page 79. So can you see the yellow box? The total current is equals to the total current. So the total current in equals to the total current out. So if you have free 8 going into a point, so after that free 8 will, so the free 8 will leave. Turn your book to page 81. Do check point 3. Question number 1 and 2. Do check point 3. Question number 1 and 2. Page 81. Check point 3. Question number 1 and 2. Okay, so what's the device with the symbol A? Yes, the emitter. Okay, so here are capacitor to measure the current, okay? So, and you need to state the unit of each current. Okay, so what's the values of I1? What's the values of I1? 2A. So how about I2 and 3?
1A.
1A and then 4.
2A.
2A. Okay, so again, this question is low B, but do you remember why? So will the current consumed by the circuit? So the electric component only use the voltage, but not the current. Okay? So if here is 2A, then the current doesn't change even if it's passed through the resistor or the other electric component. Okay? So it keeps 2A's. And then at this point, the current splits into two parts, so 1A and 1A, and finally they combine and then becomes 2A again. Okay, so question number 2 is a bit difficult, so we'll try to do that. Give you 1 minute. Okay, so it seems very difficult for you to determine the values of I, right? So there are lots of different currents. So, but the key point is that the current flowing in to a circuit equals to the current flowing out from the circuit. Okay? So altogether, so how what's the magnitude of current flowing into this networks? So the current flows in. What's the values of current flows in to this network? Melody. 哦，冇嘢啦。有幾多個 current 行咗入去啊？你會自己數下咯。Okay, so this 2A current is flowing in, 3A current is flowing in, 4A current is flowing in, and then this 2A is flowing in, right? So altogether, the current flowing is 2 plus 3 plus 4 plus 2, so equals to 11A. Okay? So and then we want to find I. So the current flow out is 1 plus 2 plus I, right? So and the magnitude of current flow in should equal to the magnitude of current flow out. So 1 plus 2 plus I should equal to 11. So I is 8. So if you can't understand, you can imagine the wire as the water tube, okay? And then the current is the water flowing in. So if you have 11 liters of water flowing in, then you need to have 11 liters of water flowing out. Okay, so in order to balance this network, okay.一定要 out 因為你入係11啊嘛。咁如果你唔 out 嘅話，呢個咪得3個係 flowing out。即係你 flow out 嘅 equals to flow in 係啊。即係好似你翻學咁樣，你入咗幾多學生，你最後要出翻幾多學生 ？OK？ 點知道係 flow out？ 因為你見唔見到呢啲係嗱？你由呢個點開始睇呢度係咪 flow in 啊？即係佢行入去啊。咁你而家要計呢個啊嘛係嘛？你諗下，如果你唔睇呢個 R 叫 flow out 嘅係咪得 only free A flowing out 啊？咁所以佢你 flow in 嘅11，你 flow out 嘅得 free 咯，你唔計呢個，咁你知道呢個肯定係 flow out， 因為你入嘅同出嘅要一樣。咩叫 C 啊？The unit of charge is C. The unit of I is ampere. Okay. So now let's ask you a very abstract question. So do you think current is a factor? Is current a factor?
No.
係咪淨係有方向就可以叫做 factor? Okay. So what is a factor? So factor has direction and magnitude, right? So if you have two force pushing the same object, so what's the net force of this object? Zeros, right? However, if you have two types of current flowing to same point, so will the current become 0? No, the current will become 4A. Okay? So actually, the current won't obey the Adam's laws of factors. So current is not a factor. Okay? 如果冇一條管向上，呢度就當初就唔會有 current 流過嚟。嗱，即係你咁樣諗，你就當佢係水咁樣諗嘅啫。你原本有2 lit 嘅水流過嚟，如果呢度有條管，係咪有4 lit 嘅水流出去啊？咁但係咧，如果呢度有2 lit 嘅水，呢度有2 lit 嘅水，但係呢度係冇開口嘅，咁會唔會流到嗰啲水？你當初就流唔到，唔信你揾嘅同學嘴一啖。即係你而家吹氣。即係我同你駁住2條管啦，我同你駁住2條管咧，唔好我，你同佢駁住2條管喺度吹氣，咁係咪吹到上去啊？但係咧，你直接啜啊大 Anna， 你吹氣會唔會吹到？吹唔到出嚟。你試下而家。即係你想象下都得係咪？你真係，即係佢當初就唔會有水流出嚟。咁會有水流入去呢條管嘅冇嘅發生。唔係啦，你可以諗下啲 current 係點樣流出嚟嘅，即係呢度係，譬如呢度係 positive terminal， 呢個 positive terminal， 呢個 negative terminal 啦，係咪？咁樣佢就會流去呢度啦，所有。咁但係咧，如果呢個情況即係點啊？呢度係 positive terminal， 呢個 positive terminal。咁其實佢當初，因為佢哋有 same potential， 所以啲 current 係唔會流，本身就唔會流啦，當初嘅時候。係啊，就唔會有呢個 current 出現咯。即係如果冇地方俾佢出去嘅話，即係如果電池兩邊都係正嘅，係2啊！你駁錯咁多次你都唔知。冇啊，我錯啱㗎。不過咧，呢個唔係好重要，你知道佢唔係 factor 就得啦。OK。So the only thing you need to know is current is not a factor. Okay, So and then turn your book to page。有咩想問啊？呢個如果你真係好想了解清楚，因為你而家問咗先啦。Crystal 有咩想問啊？首先兩句想問。你可以翻屋企試下啦。咩啊？你講，你想問？佢有 direction， 但係佢唔會 obey 即係 the laws of mathematics about factors 咯。即係佢唔會 cancel 啊！即係佢唔會相減嘅時候唔會 cancel。佢有 direction， 但係佢唔係 factor。factor 有 direction， 有 value， 有 obey max 嘅 factors 嘅 law 嗰啲。即係佢呢個 direction 係類似時間咁樣咯，即係你時間向前行定向後行，但係時間本身唔係一個 factor。你有冇睇過天能嘅？有時都係。時間會向後行。Okay, so turn your book to page 86. Page 86. Page 86. 唔喺後面好多時候用到呢個 parent 同 foliage 嘅觀念，有100幾十題 exercise 俾你去練習。OK， so now 嗱呢個就係你哋最想問㗎啦。OK, so what is foliage? OK, so there are lots of different names for foliage. OK, so the most common one is called foliage. Okay, however, okay, so if you see EMF, okay, so which is electromotive force, that is also a voltage. It's not a force. And when you see PD, the potential difference is still a voltage. Okay, so they are different names of voltage. So why do we need to have 3 names? So I will give you an example, then you will know that. Okay, so if you have a battery, 鬧我啦，揾個同學鬧我啦，我啱啱講錯咗啲咩啊？係啦，呢粒唔係 battery， 呢個係 cell。咩先係 battery 啊？好多粒先係 battery 啊嘛，係咪啊？所以你英文作文寫下 battery 應該要俾人扣分㗎。Okay, so now you have a cell, and then to connect to a resistor, to 2 resistors. So if 2 resistors are identical, so the voltage of your cell is 10 V. Okay. So what is the voltage across these 2 resistors? What's the voltage across these 2 resistors? If you can provide 10 V, so what's the voltage across these 2 resistors? 5 and 5, right? So both of them are 5 V. 記唔記得點解啊？ So you carry, so the current carry 10 V, and then when it goes back to the negative terminals, so all voltage needs to be used up, right? So you need to put down 10 V before it goes back to the negative terminal. So in this case, there are 2 resistors, and they are the identical resistors. So the voltage you use for each resistor is the same, so that it consumes 5 V, it consumes 5 V. So in this circuit, we call the power supply as electromotive force. And then this 5 V as potential difference. Okay? And they are all voltage. Agnes， 你有冇做啲乜嘢啊？啊？呢度見到你眼期咯。一個人正常眨眼咧係用0.03秒咯，人嘅 reaction time 係0.24秒。如果我睇到你眨眼咧，證明已經好唔順順。你睇唔到嘅，即係如果你唔仔細留意一個人眨眼，基本上冇可能睇到。我已經見到你眨眼。因為你夾住我隻眼啊嘛，唉，真係冇。Okay. Actually, these two values are also called voltage. However, so in order to label which one is the voltage supplied, which one is the voltage consumed, so those scientists invented two words. So for the voltage supplied, we call this the electromotive force. For the voltage consumed, we call this the potential difference. And actually, both of these two words are also voltage, okay? So this is the voltage supplied. So this is the voltage consumed. Okay, so and both these two words is related to the voltage, and actually they are equivalent. So if there is no special notation, actually you can say all these values are voltage. Okay? So and now I will tell you the physical meanings of voltage. So what is voltage? There is the two equations, right? So two equations on your book. So one is so one is F equals to W over Q. So the second equation is V equals to W over Q. So what is the difference between these two equations? What's the difference between these two equations? What's the difference between these two equations? What's the difference between these two equations? Okay, so this one is for EMF, this one is for the voltage consumed. However, actually you can think that these two equations are equivalent, okay? So actually they have the similar meanings or even the same meanings. Okay, so now what is the voltage? Why do we always say that if the voltage is higher, then the energy is higher? So this equation is linked the voltage with the energy. So this W is the work done, and actually, if you are not very familiar with the term work done, you can use energy. 唔知你覺得 work done 舒服啲定 energy 舒服啲？其實 work done 就係 energy 嘅 ，work done 係 energy 嘅另一個名，你可以咁樣講，即係好似陳婉賢嘅 Irene Chan。好，所以咧voltage 咧 ，if we write down the equations in terms, so voltage equals to energy over charge. 所以係咩嘢咧？所以咧就係你買電芯嘅時候咧，你買粒金霸王或者勁亮，係咪啊？Okay, so if you buy a 1.5V battery, so then the left-hand side will be 1.5V, right? Okay, so what's the right-hand side? So if there is 1 coulomb of charge passed through this battery, if there is 1 coulomb of charge passed through this battery, then the batteries will provide 1.5V times 1C equals to 1.5 joules. Okay, so again, 個 calculation 好低 V 啦，你要諗一諗個 concept， 即係咩意思咧？你買一粒 1.5V 嘅電芯 ，if there is 1 coulomb of charge passed through this battery, then the battery provide 1.5 joules. Okay, so now you 係啊，俾咗啲 energy 啲 electron，唔係我查一查。手尖啊，手掌。 本嗰啲插頭咧係110V，即係咩意思啊？日本啲插頭係110V，即係咩意思啊？即係如果有一個 coulomb 咁多個 charge， 如果你想像到一個 coulomb 咧，你就諗有好多嘅有一個 mole 嘅 electrons pass through 佢啦。咁啲 electrons 咧經過呢個 battery 嘅時候咧，會得到 energy 嘅。electrons 或者 current 咧經過呢個 power supply 或者呢個 battery 嘅時候會gain energy 咯。咁咧佢嘅 energy 咧就係110 joules。咁咧如果係220V咧，咁你而家都知道啦，220V咧就係220 joules。Okay？ 所以點解咧？你喺日本叉電咁慢啊？或者你喺日本或者內地叉電點解咁慢咧？就因為佢哋嘅 voltage 係110V。咁所以咧，你叉電咧就會慢過喺澳門係220V。So if you have same amount of current, so to pass through the socket and then to bring the energy into your phone, then the energy will decrease to half. Okay? 即係你喺澳門叉電同喺日本叉電，如果有同樣嘅 charges 咧，去攞嗰啲 energy 嘅話咧，你喺澳門叉咧就係220 joules， 喺日本叉就係110 joules。澳門會快啲，但係咧你漏電嘅時候就會容易電死。係啊，你電死都電得快啲。你可以嗱，咁咧嗱，算啦，大家都唔需要咁我再寫一個你就明啦。我諗住一陣間先寫，但係你哋求足太強啦。我決定你用 break 嘅時候為大家寫。譬如咧，你澳門就係110V，係咪？澳門200。以為我意思，日本就係110V。如果一粒 electron 可以攞到幾多 energy 啊？一粒 electron 你會用一粒 electron 嘅 charge，OK？ 每粒 electron 咧就可以攞到咁多嘅 energy， 即係每粒 electron 就可以攞到。有冇計錯啊？
冇計錯。
啊？
冇計錯，但係 unit 係做。
unit 係做。即係喺日本咧，每一粒 electrons pass through 嘅 socket 咧 can gain 1.76 times 10 to negative 19 joules. So in Macau, so for every electrons, so the energy is doubled. Okay, so due to the voltage, so which is 3.52 times 10 to negative 70 joules. Okay. A lot of electrons. So this is the physical meanings of voltage. So the electrons can gain more energy when this pass through the power supply. Okay, so you can take a 2-minute break first.